Welcome to Lasea class. I am your teacher, Jan Lasea.
A blessed day to everyone. Today, we are going to learn long distance remote control 2G GSM using Arduino Uno microcontroller, Salang GSM Shield, relay, and USB LED bulb. The Global System for Mobile Communications, or GSM, is a standard developed by the European Telecommunications Standards Institute to describe the protocols for second generation digital cellular networks used by mobile devices, such as mobile phones and tablets. 2G is a short notation for second generation cellular network, a group of technology standards employed for cellular networks. 2G was commercially launched on the GSM standard in Finland in 1991. Radio signals on 2G networks are digital. It uses digital signaling to connect cellular radio towers to the rest of the mobile network system. 2G was superseded by 3G technology. The status of 2G GSM in the Philippines. The Globe Telecom shut down the 3G network only, and 2G still remain active while promoting the 4G and 5G LTE networks. On the other hand, Smart Telecom shut down both the 3G and 2G networks while promoting the 4G and 5G LTE networks. We can use this technology as an alternative to Internet of Things. In my case, I cannot connect online my Arduino Nano 33 IoT device on both Arduino IoT Cloud and Blink Cloud servers using pre-plan. The materials we need to build a simple project are Salang GSM Shield. The Salang GSM Shield adds SMS, GPRS, and data call capabilities to your Saling Uno or Arduino Uno projects. The board greatly simplifies implementation with its Arduino Shield form factor and integrated supporting circuits. You can purchase the materials at the Layad Circuits, Electronics, Engineering Supplies and Services, located at room B314, Lopez Building, Session Road, Baguio City, Philippines. Or you can visit their Facebook written in this slide. Next, we need to have a Arduino Uno or Salang Uno microcontroller. The Salang Uno microcontroller board is an Arduino compatible board based on the 8-bit Atmega 328P microcontroller. Its design is nearly identical to the Arduino Uno version R3, but with several enhancements. Next, you need to purchase the Globe Telecom 4G or 5G LTE SIM card and register first at Globe Telecom website in order to use it. And then after that, you insert the SIM card in this location of the Layad GSM Shield. And then you attach the Layad GSM Shield on the Salang Uno or Arduino Uno microcontroller. We need also to use a small breadboard. Next, we need to use 5-volt relay module. We use the 5-volt relay module to switch on or off the USB LED bulb. we can connect the USB bulb in this normally open port and the common port. Next, we need to have a 5-volt USB LED bulb. We need also to have a Type A female USB port connector so that we can connect it to the 5-volt USB LED bulb. Note that the Type A female USB port connector, this pin will be connected to the ground, whereas this pin will be connected to the positive power supply or the BCC. We need also to have a white LED or any colored LED with a 220 ohm resistor. We need jumper wires and USB cable for Arduino Uno. We need to use the Arduino CC++ IDE. The version that I use is version 2.2.1 for Windows 11. But you can also use the old version 1.8 for Windows 7. We need to use a computer to write sketches or programming codes to be uploaded to the Salang Uno or Arduino Uno microcontroller. This is the wiring diagram for our simple project. First, we need a separate 5-volt power supply for the USB LED bulb. Although we can use the 5-volt of the Salang GSM Shield, but it will stress out when the current is not enough. So it is safe and better to separate the power supply. We connect the ground and 5 volts from the separate 5-volt power supply to the negative and positive rails of the small breadboard. We go to the 5-volt relay. The BCC pin of the relay will be connected to the 5-volt of the Salang GSM Shield. The ground pin of the relay will be connected to the ground of the Salang GSM Shield. The signal pin of the relay will be connected to the digital pin number 8 of the Salang GSM Shield. The normally open pin of the relay will be connected to the positive pin of the Type A female USB port connector. The common pin of the relay will be connected to the 5-volt. It will be connected to the 5-volt rail of the small breadboard to power the USB LED bulb. Next, we go to the white LED bulb. The anode pin of the white LED will be connected to the ground rail of the small breadboard. The cathode pin of the white LED will be connected to the 220 ohm resistor. The 220 ohm resistor will be connected to the digital pin number 12 of the Salang GSM Shield. Next, we go to the small breadboard. The ground rail of the small breadboard is used as a common ground. The grounds of the Salang GSM, the Type A female USB port connector, the relay, and the separate 5-volt power supply are connected to the ground rail of the small breadboard as common ground so that they will function properly. Let us look at the program codes to be uploaded to the Salang Uno or Arduino Uno microcontroller. In our code, we include one header file named software serial.h. We instantiated the class software serial and declare an object named mySerial and pass some arguments such as the RX or the receiver digital pin number 2 and TX or the transmit digital pin number 3. Next, we read some defined directives such as LED assign as the digital pin number 12 to control the white LED. Relay assign as digital pin number 8 to control the 5-volt relay. Finally, we declare some global variables to store information such as an array of characters named SMS RX message MSG, an array of characters named SMS sender, and a string named MSG. The method or function setup is run once by the microcontroller. The beginning codes will turn off both the white LED and relay using the two commands, pin mode and digital write. Next, we call the function begin and pass the argument baud rate of 9600 of the two objects, namely serial and mySerial. Next, we pause for 20 seconds so that the GSM modem has enough time to boot up and register. Next, using the command mySerial.println, we establish some AT commands. AT is an abbreviation of attention. GSM or GPRS modems and mobile phones support an AT command set that is specific to the GSM technology, which includes MSS related commands like AT plus CMGS, which means send SMS message. Another AT plus CMSS, which means send SMS message from storage. Another is AT plus CMGL, which means list SMS messages. Another is AT plus CMGR, which means read SMS messages, and many more. This is the continuation of the code of the function setup. The function feedback serial will display to the Arduino IDE serial monitor the results of issuing an AT command. The AT command AT plus CSQ will determine the signal strength. For example, the signal strength of my test is signal strength 14, but 31 is the best signal. Next, the AT command AT plus CCID will determine the SIM card ID number, not the SIM card phone number. This determines if there exists a SIM card inserted to the Salang GSM shield. For example, it will display the SIM ID number 89634193185514114186. Another AT command is AT plus CREG question mark. It will check if the SIM card is registered in a network. For example, the output of that will be registered home network. Another AT command is the AT plus COPS question mark. It checks if the SIM card is connected to the network. An example output of this is that network is connected to Globe Telecom. Another AT command is 80 plus CBC. It returns the status of the phone's battery. For example, battery full, 67%. The voltage is 3.94. Finally, it will print the message, ready to receive SMS. The command digital write will turn on the white LED to signal us that Salang GSM is ready to receive any SMS message. The function send text message is used to send text message to a phone. For example, we send a text message, hello world, to the phone number plus 639051234 The function loop is called repeatedly by the microcontroller. The while loop statement will check if there is a SMS received. If there is SMS received, then this sub loop statement will get one character received per 500 milliseconds at a time. The message received. The entire message will be stored at the variable MSG. This is the continuation of the code function loop. The if decision statement checks if there is a message received and it will extract the message on or off, written in all capital letters. The following code inside the body of the if statement will get the phone number of the sender and the message. This is the continuation of the code of the function loop. The body of the if decision statement will extract the phone number of the sender and store to the array of the character variable name SMS sender. Finally, the commands serial.print and serial.println will display the phone number of the sender and the message sent to the serial monitor of the Arduino IDE. This is the continuation of the code of the function loop. The if-else statement will perform an action. For example, if the message is on, then it will switch on the relay to turn on the bulb. If the message is off, then it will switch off the relay to turn off the bulb. And also, it will call the function send text message that it will send a message feedback such as the bulb is turned on or the bulb is turned off to the sender's phone number. Ladies and gentlemen, let us run and test. Let us wait for 20 seconds that the Layad GSM Shield will accept any SMS messages. When this LED will turn on, that means that it is ready to accept any SMS messages. Now that it is turned on, let us operate our cell phone. Let us send a on message to turn on the LED bulb. We just send a message which is a on message. And the LED bulb turn on. It will also send a feedback message that the message is bulb is turned on. Let us turn it off. The bulb is turned off and we will wait for the feedback message sent by the Layad GSM shield. The bulb is turned off. Let us turn it again. Turn it on again. So I will type the message on and then send it again. And the feedback sent by the GSM shield is bulb is turned on. Let us turn it off for the last. I type the command off written in all capital letters and then send. And then the feedback is the bulb is turned off.
That ends our topic for today. I hope you are inspired in my class. Thank you for watching. God bless us.